Dear students, Namaskar. Welcome to the class. Today we are going to discuss grade 10, subject mathematics, lesson 12. Circle, you have seen here 4, means this is the 4th class of circle. In previous classes, what we discuss different theorems of circles and we have proved them theoretically as well as experimentally. And in today's class, we are going to discuss short questions related to the circles. But before to start short questions of circles, can we review what we studied or what we proved in previous class in theorems? Look here. The first theorem that we discuss is central angle is double of the inscribed angle standing on the same arc. That is, this is circle, and you know the meaning of central angle. To take central angle, take anywhere 2 points on the circumference. Now join AO and BO. Then AOB is central angle standing on the arc AB. Now on major arc AB, take anywhere point C. Now with the help of ruler and pencil, join AC and BC. Then ACB is inscribed angle standing on the arc AB. So AOB is central angle and ACB is inscribed angle. Both are standing on the same arc AB. Yes. Now what we proved, central angle is double of inscribed angle. That is, AOB is 2 times of angle ACB. Or you may say angle ACB is half of angle AOB. And we have already proved this theorem theoretically as well as experimentally in previous class. So this is only just for review. Similarly, in next theorem, what we discuss, the angle in a semicircle is a right angle. So right angle means an angle of 90 degree. So firstly we draw a circle and semicircle. So diameter divides the circle into two semicircles. So to get semicircles, we draw diameter. Suppose the name of diameter is AB. Now we have seen here 2 semicircles. This upper one above the diameter AB is one semicircle and below the diameter AB is another semicircle. So in any semicircle, take anywhere point C. I am taking point C on the circumference of upper semicircle. AC, C. Now join AC and BC. Then ACB is inscribed angle or angle at the circumference made by diameter. So angle ACB is called angle in a semicircle. And what we have proved about angle in a semicircle is 90 degree. That is, angle ACB is 90 degree, and we have also proved this theorem also experimentally as well as theoretically. Similarly, what was the third theorem that we discussed? Angle at the circumference standing on the same arc are equal, or this theorem may be stated as inscribed angle standing on the same arc are equal, or this theorem can be stated as angles in the same segment of a circle are equal. And this theorem also we have proved theoretically as well as experimentally. So for angles in the same segment, firstly we draw a circle with center O. Now take an arc of length anything. Now this is arc AB. So on major arc AB, take anywhere point C, join A and D, then join AC and CB. Similarly, join AD and DB. What you have seen here, angle ACB is inscribed angle standing on the arc AB, and angle ADB is also inscribed angle standing on the same arc AB. And what we proved that these 2 angles are equal. We proved it theoretically as well as experimentally in previous class. That is, angle ACB equals to angle ADB. Similarly, in last theorem, what we proved that the opposite angles of a cyclic quadrilateral are supplementary. Supplementary means the sum of 2 angles is exactly 180 degree. And opposite angles of a cyclic quadrilateral are supplementary means when we add opposite angles of a cyclic quadrilateral, then sum is exactly 180 degree. For this also, we have drawn a circle with center O. Take anywhere 4 points on the circumference. Join AB with the help of ruler and pencil. Similarly, join BC also with the help of ruler and pencil. Join CD with the help of ruler and pencil. Join AD also with the help of ruler and pencil. Then ABCD is a cyclic quadrilateral. Yes. Now, opposite angles are supplementary, means angle A plus angle C is 180 degree. A means angle BAD, C means angle BCD. So, angle BAD plus BCD equals to 180 degree. Similarly, angle ADC plus angle ABC is also 180 degree. And we have proved this theorem also theoretically as well as experimentally. So, these are only for revision. Basically, today we are going to discuss short questions related to these theorems. Are you ready? Yes. So, the first question is this. Look here. In the given figure, O is the center of the circle. Look here, O is the center of the circle. And O lies on AB. So, what is AB? Yes, correct. AB is the diameter. Why? Because AB is a chord that passes through the center. That's why AB is the diameter. Then we have to find the value of x. We are given angle PBA, how many degree? 35 degree. So, how can you find the value of x from here? Firstly, write the given. Angle ABP is 35 degree. Yes. And O lies on AB. So, AB is the diameter. And we have discussed that angle made by diameter at the circumference is called angle in a semicircle. And we proved in previous class, angle in a semicircle is 90 degree. So, this APB is inscribed angle standing on the diameter. So, this angle APB is how many degree? 90 degree. It is an angle in a semicircle. So, this angle is 35 degree. This angle we have calculated how many degree? 90 degree. Now, in triangle APB, if we use sum of angles of a triangle, then we can calculate this angle. Can we? Because in any triangle, if two angles are known, then we can calculate the third angle by using the concept sum of angles of a triangle is 180 degree. And after calculating this angle, this is inscribed angle standing on the arc PB, and this x is also inscribed angle standing on the same arc PB. And we know the relation inscribed angle standing on the same arc are equal. So, x equals to angle PAB. That's why firstly we take triangle APB, and in triangle APB, if we add all three angles, that is angle ABP means this angle plus angle APB plus angle BAP, then it will be 180 degree. Now, put the values. ABP we have 35 degree, that's why we have written 35, APB 90 degree, BAP same equals to 180 degree. You know that 35 plus 90 becomes 125, and when it goes on right hand side, it becomes minus. So, we can write angle BAP equals to 180 degree minus 125 degree. 180 minus 125 is 55 degree. So, BAP means this angle we have got 55 degree, but this is inscribed angle standing on arc PB, and x is also inscribed angle standing on the same arc PB, and we know that inscribed angle standing on the same arc are equal. So, what we can write, angle PQB means x equals to angle BAP. Why? Because PQB is inscribed angle standing on arc PB, and BAP is also inscribed angle standing on same arc PB, so they are equal. So, PQB means x, and BAP we have calculated 55 degree. That's why the value of x in this figure is 55 degree. Have you understood? Now, move to another type of question. Look here. In this figure also, O is the center of the circle. Then we have to find the value of x. We have already discussed in previous class. Here also, the name of this upper angle AOC and lower angle AOC. This upper angle AOC is more than 180 degree, so we call it reflex angle AOC, and lower angle AOC is 130 degree, which is less than 180 degree, so we call it obtuse angle AOC. Now, how can we calculate the value of x? Very simple. This x is inscribed angle standing on the major arc AC, and this major arc AC subtends reflex angle AOC. So if we have the value of reflex angle AOC, then inscribed angle is half of reflex angle AOC. That's why firstly we calculate reflex angle AOC. But what we are given? We are given this obtuse angle AOC. So we are writing obtuse angle AOC equals to 130 degree. But reflex angle AOC means this upper angle plus obtuse angle AOC. If we add these two angles, reflex angle AOC plus obtuse angle AOC, then we get one complete rotation. And we know that one complete rotation is 360 degree. So what we can write, reflex angle AOC, this upper one, plus obtuse angle AOC, this lower one, equals to 360 degree. Why? Because sum of angles formed at a point, because both angles are formed at same point O in a complete rotation. That's why 360 degree. Now put the value of obtuse angle AOC, reflex angle AOC as above. And instead of obtuse angle AOC, what we can write here, 130 degree. And if I send this 130 degree on right hand side, then this becomes reflex angle AOC equals to 360 minus 130. 360 minus 130 is 230 degree. That's why reflex angle AOC is 230 degree. But we have to find angle ABC. Now reflex angle AOC is standing on the major arc AC, and angle X, that is angle ABC, also stands on the same major arc AC. So what we can say, angle ABC is half of reflex angle AOC. Why? Because inscribed angle is half of central angle standing on the same major arc AC. Look here. This reflex angle AOC stands on major arc AC, and inscribed angle ABC also stands on same major arc AC. Now put the value of reflex angle AOC. Angle ABC means X, half same. Instead of reflex angle AOC, what we can write, 230 degree. And if you divide 230 degree by 2, then it will be 115 degree. That's why the value of X is 115 degree. Yes, any confusion? Okay. Now move to next type of question. In this question also, O is the center of the circle. O is the center of the circle, then AB is called what? Yes, you are correct. Then AB is called diameter. And you know that then angle ACB is called angle in a semicircle, and we know that angle in a semicircle is how many degree? 90 degree. And we are given angle CAD, either you can say angle CAD or you can say angle CAB equals to 50 degree. Can you? Yes, or you may say it DAC, which is 50 degree. So write angle DAC equals to 50 degree. And this angle ADC, this is the symbol of right angle. So angle ADC is 90 degree, you can write. We have to find this angle X. How can we find this angle X? Any idea? Yes, good try. Look here. Now ADC is a triangle. And in triangle ADC, two angles are known, this and this. So by using the concept sum of angles of a triangle, we can find this angle, which is angle ACD. But this whole angle ACB is how many degree? 90 degree. Why? Because AB is a diameter and angle ACB is in a semicircle. So whole angle is 90 degree, whereas this ACD we have calculated. So from whole angle 90 degree, if we subtract this angle, then we get the value of X. This is the main concept. So firstly, from angle ADC, we are going to find this angle, which is angle ACD. Look here. Angle DAC means this angle, plus angle ADC means this angle, plus angle ACD means this angle, equals to 180 degree. Reason, sum of angles of a triangle. Now put the value of angle DAC. What is the value of angle DAC? 50 degree. And ADC 90 degree. This ACD as above, 180 degree as above. Now 50 plus 90 becomes 140. And when it is sent on right hand side, it becomes minus 140. So angle ACD equals to what we can write? 180 minus 140. 180 minus 140 becomes 40 degree. So ACD we have calculated 40 degree. and we have discussed earlier also, this angle ACB is angle in a semicircle. So what is the value of this whole angle? 90 degree. Whereas this ACD is 40 degree. Now can you guess what will be the value of x? Yes, you are correct, 50 degree. Why? Because from whole this angle, if I subtract this angle, that is 90 minus 40 becomes 50. So we are doing the same. So firstly we are writing angle ACB equals to 90 degree. Because ACB is angle in a semicircle, that's why 90 degree. But in the figure, ACB has two parts. One part is ACD and other part is BCD. So ACB equals to what we can write? BCD plus angle ACD. Can we write? And result, whole parts axiom. In geometry, when two or more than two parts are added and we get the single part, then it is called whole parts axiom. Now put the value of angle ACD and BCD. So BCD is x, whereas ACD is 40 degree. And when I send this 40 degree on right hand side, it becomes minus 40 degree. So x equals to 50 degree. In this way, we can find the value of x. Okay. Now, can we move to another question? This question. In this figure, also, O is the center of the circle. Then in this figure also, AB is the diameter. AB is the diameter. We are given the value of angle AOC, which is 130 degree. And we have to find the value of x. So we are given angle AOC 130 degree. And we have to find the value of x. How can we find? Yes, good try. Look here. This x means angle BDC. And this angle BDC is inscribed angle standing on arc BC. Does arc BC subtends any other angle? Yes, you are correct. Arc BC subtends central angle BOC. And we know the relation of central angle and inscribed angle. That is, inscribed angle is half of the central angle. So angle X is half of angle BOC. But for that, we need to find the value of angle BOC. How can we find the value of angle BOC? Think for a moment. Yes, you are correct. If I add AOC and BOC, that is AOC plus BOC, if I add this angle and this angle, then we get a straight line. And a straight line means, 180 degree. That's why we can write angle AOC means this angle, AOC plus angle BOC, this angle plus this angle. Can you get a straight line by adding these two angles? So a straight line means 180 degree. That's why angle AOC plus angle BOC is 180 degree. Reason we have written here linear pair. Linear means a straight line, pair means two. Means by adding these two angles, we have got a straight line. That's why the sum of these two angles is 180 degree, because a straight line means 180 degree. Now if we put the value of angle AOC, instead of AOC we can write 130 degree, BOC as above equals to 180 degree. And if I send this 180 degree, 130 degree on the right hand side, then angle BOC equals to, we can write 180 minus 130, which is 50 degree. So BOC central angle we have calculated. Why we have calculated central angle BOC? Because central angle BOC is standing on the arc BC, and this X is inscribed angle. This also stands on the same arc BC. And we know the relation of central angle and inscribed angle. What relation we know? Inscribed angle is half of the central angle. That is, angle BDC is half of angle BOC. Reason, inscribed angle is half of the central angle standing on the same arc BC. Now, what is the value of angle BOC? You have got 50 degree. So, and instead of BDC, what we can write? X. So, X equals to, instead of BDC, we have written X, half same, times angle BOC, which is 50 degree. And when you divide 50 degree by 2, it becomes 25 degree. That's why the value of x is 25 degree. Got it? Yes. So can we move to another question? Look here, another question. In this figure also, O is the center of the circle. Then we have to find the value of x. And again, this x is what type of angle? Yes, you are correct. This x is inscribed angle standing on arc AB. Yes. Does arc AB subtends any central angle? Yes, you are correct. Arc AB subtends central angle AOB, and same arc AB subtends inscribed angle ADB. So if we can calculate this central angle AOB, then the value of x is half of angle AOB. But the question is, how can we find the value of angle AOB? Do you have any idea to find the value of angle AOB? Yes, correct. Look here. This OA is radius of the circle. OC is also radius of the circle. And you know that the plural of radius is radii. So OA and OC are radii of the same circle. And we know that radii of the same circle are equal. That is, we can say OA equals to OC. So OA equals to OC means in triangle AOC, two sides are equal. So in any triangle, if two sides are equal, then that triangle is called isosceles triangle. It means AOC is an isosceles triangle. And we know that base angles of an isosceles triangle are equal. Base angles means angles that are opposite to equal sides. So equal sides are here OC and OA. So one angle, angle opposite to side OA is angle ACO, that is this. And angle opposite to side OC is angle OAC, which is 50 degree. So if this is 50 degree, this will be also 50 degree. Base angles of an isosceles triangle. But to find the value of x, which angle we need? We need central angle AOB. We need central angle AOB. How can we calculate central angle AOB? You know that you have studied in class 9 that if a side of a triangle is produced, then you get an exterior angle. And exterior angle is equals to sum of opposite to interior angles. So this for triangle AOC, side CO is produced to B. That's why AOB is an exterior angle. And exterior angle equals to what we know? Sum of opposite to interior angles. So angle AOB equals to, we can write 50 degree plus 50 degree, which is 100 degree. So AOB will be 100 degree, central angle 100 degree. Then inscribed angle is standing on the same arc will be half of central angle, that is x equals to 50 degree. Have you understood? Now can we start the solution? Yes, correct. Look here. This OAC is 50 degree. And now look here. Angle OAC equals to, we can write angle OCA. Why? Because OA equals to OC due to radii of the same circle. And these two angles are base angles of an isosceles triangle. So this will be also 50 degree. Now, we have already discussed that when a side of a triangle is produced, we get an exterior angle. So in triangle AOC, side CO is produced to B. So AOB is an exterior angle. And exterior angle equals to what we know? Sum of opposite to interior angle. So what we can write? Angle AOB equals to angle OAC plus angle OCA. Same we are writing. AOB means exterior angle equals to angle OAC plus angle OCA. Why? Because we know that exterior angle of a triangle is equal to the sum of opposite to interior angles. Now put the values. OAC we have calculated, OAC is given 50 degree and OCA also we have written 50 degree. So AOB is 100 degree. So what we have got? We have got central angle AOB standing on the arc AB. And we have to find x. So x is inscribed angle standing on the same arc AB. So what we can write? Angle BDA, which is inscribed angle, is half of central angle AOB. Why? Because both are standing on the same arc AB. Then inscribed angle is half of central angle standing on the same arc AB. Now put the value of angle AOB. What is the value of angle AOB? 100 degree. So BDA means x, half as above, times angle AOB means 100 degree. This gives you x equals to 50 degree. Got it? Okay. Can we move to another question? Look here, another question. In the given figure, O is the center of the circle. Look here, O is the center of the circle. FAEC is a cyclic quadrilateral. FAEC is a cyclic quadrilateral. And we are given this CED 68 degree. Do you know the meaning of this angle CED? Yes, you are correct. If a side of a cyclic quadrilateral is produced, then we get an exterior angle. We get an exterior angle. So CED is exterior angle of a cyclic quadrilateral, which is 68 degree. Then what we have to find? We have to find the value of angle AFC. AFC means this inscribed angle. Then we have to find the value of reflex angle AOC. This upper one is reflex angle AOC and lower one is obtuse angle AOC. So we have to find reflex angle AOC means upper angle. How can we find? Firstly, right, we are given exterior angle, angle CED 68 degree. Now how can we find angle AFC and reflex angle AOC? Look here, if I add angle AEC and angle CED, then we get a straight line. By adding these two angles, angle AEC and angle CED, we get a straight line. And a straight line is how many degree? 180 degree. So we can write angle AEC, or you can write angle CEA plus angle CED equals to 180 degree. What region we have written here? Linear. Linear means a straight line. Pair means two. So by adding two angles, we have got a straight line. That's why what region we have written? Linear pair. Now put the value of angle CED. CEA as it is. Instead of CED, what we can write? 68 degree. Send 68 on the right hand side. Then 180 minus 68, which is 112 degree. So CEA we have got 112 degree. But which angle we have to find? AFC. Now check here. AFC and CEA are what type of angles? Yes, you are correct. They are opposite angles of a cyclic quadrilateral. And we have learnt in the theorem that opposite angles of a cyclic quadrilateral are supplementary. That means when we add opposite angles of a cyclic quadrilateral, sum will be how many degree? 180 degree. That's why what we can write, angle AFC plus angle CEA equals to 180 degree. Reason, opposite angles of a cyclic quadrilateral are supplementary. Now put the value of CEA, which is 112 degree. AFC as above. Instead of CEA, we have written 112 degree equals to 180 degree. Now if I send this 112 on the right hand side, then it becomes 180 minus 112. That is angle AFC will be 68 degree. So we have calculated the value of angle AFC, that is we have solved one number question. Similarly, now we have to find reflex angle AOC. Look here, reflex angle AOC is central angle standing on major arc AFC. And this major arc AFC subtends which inscribed angle? AEC. And we know that central angle is double of inscribed angle standing on the same arc. So reflex angle AOC equals to what we can write? 2 times angle CEA. Can we? Look here. Reflex angle AOC equals to 2 times angle CEA. Why? Reflex angle AOC is central angle standing on arc AFC, and CEA is inscribed angle standing on same arc AFC. So central angle is double of inscribed angle standing on same arc AFC. Now put the value of angle CEA that we have calculated here. The value of CEA we have calculated here 112 degree. So reflex angle AOC as it is 2 times, instead of CEA what we can write? 112 degree. So 2 times 112 degree is 224 degree. That is reflex angle AOC is 224 degree. Got it? So we have solved second number question also. Can we move to another question? Okay, look here, another question. In the given figure, means in this figure, AOB is diameter. AOB is diameter. And ADC, which is inscribed angle, is 100 degree. Then we have to find the value of angle BAC, this sticked angle. We have to find the value of angle BAC. So which angle we are given? We are given angle ADC 100 degree. And we have to find angle BAC, this angle. Do you have any idea how can we find angle BAC? Think a moment. Yes, good try. This AB is a diameter. So angle ACB is in a angle in a semicircle. And we know that angle in a semicircle is a right angle, that is 90 degree. So this ACB will be 90 degree. Yes. So we have got one angle of triangle ACB. Now again ABCD is a cyclic quadrilateral. ABCD is a cyclic quadrilateral. And we know that opposite angles of a cyclic quadrilateral are supplementary. So look here, which angle is opposite to angle D? Angle B. So we can write angle B plus angle D equals to 180 degree. And if we put the value of angle D 100 degree, then what will be the value of angle B? The value of angle B will be 80 degree. So in triangle ABC, we have got the values of two angles, one ACB 90 degree and other angle ABC, how many degree? 80 degree. And we know that in any triangle, if the value of two angles are known, then we can easily calculate third angle by using the theorem sum of three angles of a triangle is 180 degree. So if we add this angle plus this angle plus this angle equals to 180 degree, and if we put the values of these two angles, we can get angle BAC. So have we got idea how to find angle BAC? Okay. So now we move to the solution. So ABCD is a cyclic quadrilateral where angle D and angle B are opposite angles, and we know that opposite angles of a cyclic quadrilateral are supplementary. So what we can write, angle ADC plus angle ABC equals to 180 degree. Look here, ABC means this, ADC means this, 180 degree. Opposite angles of a cyclic quadrilateral. The value of angle ADC is known. So put the value of angle ADC, angle ABC as above. Instead of angle ADC, we have written 100 degree equals to 180 degree. And if I send this 100 degree on right hand side, then it becomes 180 minus 100, which is 80 degree. So we have got angle ABC 80 degree. So one angle of triangle ABC we have calculated 80 degree. Now which angle can we calculate? Yes, you are correct. AB is the diameter. So angle ACB is in a semicircle, and we know that angle in a semicircle is right angle. So angle ACB equals to, we can write 90 degree. Angle in a semicircle is a right angle. Yes. So now this angle also we have calculated. So in triangle ABC, the value of two angles we have calculated. This angle ACB 90 degree, ABC 80 degree. Now how can you calculate third angle BAC? Yes, by using sum of angles of a triangle. So in triangle ABC, angle BAC that we have to calculate plus angle ABC means this angle plus angle ACB equals to 180 degree. What is its region? Yes, you are correct. Sum of angles of a triangle. Now put the value of angle ABC and angle ACB. So keeping BAC same, instead of angle ABC, what we can write 80 degree. Instead of angle ACB, what we can write 90 degree. 80 plus 90 becomes 170. And if we write 170 on right hand sides, then it becomes 180 minus 170. That is angle BAC equals to 180 minus 170. 180 minus 170 becomes how much? 10 degree. So angle BAC that we have to calculate is 10 degree. Dear students, by using the concept of theorem, we have discussed short questions related to the theorems. Similarly, you can try the remaining questions of exercise and show to the respective teacher. Thank you very much. Namaste.